This series of short videos covers the property prediction of chemical systems. First, in the series, we will start with pure component property prediction of organic chemicals and polymer repeat units. The second, we will cover the property of mixture of organic chemicals. And the third will cover the prediction of inorganic salts in aqueous electrolyte systems, the phase diagram of non-reactive and reactive system, and solubility. As we have mentioned in episode 1, that properties are necessary for the calculation related to the product and process design. Since most chemical processes are handling the mixture of chemicals, therefore, these properties are also needed for the product and process design and many more. The computational procedure used depends on the needed property, the mixture that is the chemical system, and the condition which is defined by the temperature, the pressure, and or the compositions. In this video, we will highlight the bulk when a mixture of the chemical exists in a single phase and the phase equilibrium when the mixture exists in a coexisting phase that are in equilibrium. We will assume that the viewer know the basic theory of the thermodynamic property prediction. If not, please check the recorded video from PSE for Speed webinar series 2020 webinar 2 on property prediction. In this property prediction series, we will mainly use ProCAPE, which is our especially developed computer-aided property estimation software tool. For this video, we will highlight the property of mixtures organic system, such as the VLE, SLE, LLE, and phase diagrams based on the given mixture description. The 4 steps required for the mixture estimation are: first, the compound selection by adding the compound in the system. Next, define the condition of the organic system by giving the temperature, the pressure, and the flow rate of the compound presented in the mixture. And next, do the property estimation by selecting the property or the property functions of interest, such as the pressure temperature flux, the bubble point, the dew point, the VLE, LLE, or SLE. And the final step is to calculate and verify the result obtained. Now, the demonstration of mixture property estimations through ProCAPE will be started.
The properties estimation for organic system. In this one, 4 steps are also needed for the mixture estimations. The compound selection is used for adding the compound to the system. Then the organic system configuration, which temperature, pressure, and flow rate of the considered compound will be added. And the property predictions. In this one, there are many properties available. For example, pressure, temperature, flux, bubble point temperature, dew point temperature, LLE, SLE, and then the user can click calculation and the result will be run. For more details on it, I will give you the example of the methyl acetate and methanol mixtures. The first step, this compound have to be added into the software and then use the default condition with the unified VLE model. Then the VLE will be calculated as presented here. There is another prototype using SMS the data here to generate the graph by separating efficiency or driving force, which show the azimuthal point. And Gonkanok will further go into detail in this example. As you've seen that the ProCAPE for organic system can do a lot of function in the properties. So we further give you some example to show how easy of ProCAPE usage is. Okay, so turning now to the demonstration of the property estimation of the organic system. So this is the toolbox that provides the property resolve of organic mixture. And in addition, there is a function for estimation of the pure compound, which is the pure compound correlation. So there are four main steps in here, which is first the compound selection and second the mixture specification. These two is used for defining the problem, and next is the property prediction to select a property and calculate. And the last one is the test and validate of the property. So there are two examples that I would like to give the demonstration in this function. I will start with predict the VLE data of the methyl acetate and methanol system, same as the system that Oracle have given in the previous example before. Okay, so in step one, I will first just add a compound. The first one is methyl acetate, and then click add. And another is methanol, and then add. Okay, so now we got these two compounds and click OK. Next, after the compound are selected, the stream condition can be defined. In here, the user need to specify the stream condition and the flow of each compound. So in here, I will just give the default condition. Okay, and then go to step 3. Before user going to select the property, the thermodynamic model needed to be selected first. So in here, I will click property model, and user need to select the appropriate model for the calculation. In this case, I will select gamma phi and change the liquid phase model to, let's say, the VLE unifact 1 parameters. And now the parameter we will use for calculation will be shown in here. And then click OK. Okay. And then set out all of the other option by clicking default again and click OK. And next, I will select the considered compound in this box, which is these two. And then I will select the type of plot, which is the VLE phase diagram with the rectangular plot type. Okay. And with the x-acid, I will just select methyl acetate. And with methyl acetate liquid in here. And next, I will select the separation efficiency at the right-hand side for plotting the relationship between driving force and the liquid mole fraction of this compound. And then after I select this checkbox, it will be the different acid if comparing with the figure in the presentation of Oracle. So now all the data is ready to be calculated. I will click calculate in here, and all the calculated data will be shown. And then all the data can take to be plotted in here. Click $. Oh, sorry. So in here you can see that it's only show the one condition. So I can vary the condition in here by selected whether the temperature or pressure. I will select pressure, let's say, and vary it from 1 to 20, and with step 5, and then click calculate again, and close this one, and click $. And then you will see that, okay, now we have the 5 figure available in here. Also, the configuration can be adjusted. We also have the feature that the axis, the y-axis and x-axis can be adjusted. So now I will adjust the maximum 100 from only 20 to make the figure bigger like this. Okay, so in here the data is the same with the one that Oracle have shown before. The difference The only difference is that the y-axis will be the liquid mole fat of the methyl acetate, and x-axis will be the liquid fraction minus vapor fraction, which can be defined as a driving force between these two phases. For that reason, at the point that the x-axis equal to 0, this will indicate the azeotrope point, since the amount of vapor and liquid is equal, and there is no driving force between these two phases. Also, it can obviously seen that the azeotropic point can be moved with the pressure, as you can see in the several colors in here. So all in all, this feature is quite important for the distillation column design. Okay, and then I will close all. So after the interesting example for predict the VLE data, another example is to predict the SLE to calculate the solid solubility of the binary system for benzene phenol binary mixture. So first I will go to step 1 again and remove all compound for the previous example. Then I will start defining the compound. Let's say I will select benzene, click add, and phenol, and click add. So now we have set these two compounds at the same. Click OK. And for step 2, at the same, I will set condition as a default and click OK. Then the next step, property prediction. Okay, so in here I will just select the thermodynamic model as well with gamma pi to the VLE1 parameters and click OK. Okay, click default again and click OK. Okay, and then it will return to the property menu, and user can click organic SLE to see the SLE toolbox, and then click define button and follow the direction in order to calculate the solubility as a specific temperature or the multiple temperature. User can calculate like in any number of points depending on the preferable, and if user select the multiple point, the melting curve will be given. So I will select entire TX diagram and click OK with delta 0.2 at min mole fact as 0 and maximum mole fraction as 1, and then click OK and click finish. Then the calculated SLE phase diagram will be shown in here as a temperature versus the composition, also the melting temperature of each selected compound. Okay, so next I will close this one. So in the property list in here, there are multiple properties that can be predicted. For example, if I would like to know the bubble point temperature, I can check this and click calculate in here. And the bubble point temperature will be shown in the result interface. Next, I will close this one. So moreover, dew pressure and bubble pressure can be calculated through 3C sharp model in here. I will just click this one. And in here, all the model parameter of each pair will be given. Then user can calculate both multiple point and single point. If user needs phase diagram to be generated, the multiple point can be checked. But in this case, I will just select the 1 point temperature and click calculate. So similarly, the window result will be shown in here, along with the dew pressure and the bubble pressure parameters. Okay, so I have set out all the useful feature for the available in the organic mixture property prediction.
This was a brief overview of some basic features available in the mixture property toolbox function in ProCAPE. If you would like to know more, the manual of the mixture property in ProCAPE gives more information on all the features available and highlight their use through the workout tutorials which they can be obtained from PSE for Speed. Please contact us or visit our website for more details on ProCAPE, and don't forget to subscribe to our YouTube channel to remain updated on the new addition to the PSE for Speed. Thank you for taking your time and interest on our video.